Okay, for homework 927, I'd like you to copy all of this work and then show me the 3 words that show me that you listen. So here you go. This is a geometric. This is term number 1, term number 2, term number 3. I'm timesing by 2 right here, not adding by the same number, timesing by 2. That tells me that this graph right away is going to be geometric, going to be one of these exponential graphs that curve like that. I need you to be able to go back to the 0 term by doing the opposite of timesing by 2, timesing by a half. So if I take that 2 right there, times it by a half, gives me the 0 term 2 times 1/2, if you remember, straight across, gives me 2 over 2, which is 1. First word is saga, saga. Now I want you today to see this, that if I go to -1, -2, -3, I want you to see that you could keep going. So taking that positive 1, 1 times a half gives me 1/2. 1/2 times a half gives me 1/4. 1/4 times a half gives me 1/8. If I go back to -4, 1/8 times a half gives me 1/16. What I'm going to have you do today is practice using the explicit function to get these numbers. When I plug in x is 0, you should get 1. When I plug in x is 1, you should get 2. When I plug in x is -2, you should get 1/4. And that's what gives these exponential graphs, as you can see, as you're graphing them. First one at 0, 1, and then 1, 2, and then 2, 4, and then 3, 8 getting high. But then the low ones, -1, a half, -2, a quarter, -3, even smaller. Those are the values that make up that small curve part of this graph. So if I write the explicit function, like I'd like you to do today, the explicit function is f of x equals either that 0 term times that r number to the x power, or I could use the first term instead, not that 1, but that solid 2 right there, times that same 2 to the x minus 1 power. I'm going to have you practice using these with negative exponents, as you can see. All right, so here we go. Here's your proving grounds. I'd like you to use, let's probably use the first term 1 right here. So if I plug in x is 0, x is 1, let's do those first. Let's take that function, let's plug in for x, let's plug in 0 for x. Let's use the first term 1 right there. Where that x is, that's where I'm going to put the 0 right here. That gives me the function at the 0 term equals 2 times 2 to the -1. And here's where it gets dicey. Any number to the -1 power is the same as putting it over 1, flipping it, and having that power become positive. So 2 to the -1 is really 1 over 2 to the +1 power, which is 1/2. So I know negative exponents are kind of weird, but that 2 to the -1 power is 1 over 2 to the first. That becomes 1/2. And then because I'm timesing that 2 times 1/2, that gives me the function at the 0 term is 2 over 2, which equals 1. Should match that first coordinate right there. X is 0, y is 1. All right, I'm going to have you plug in 1 and then a couple of the negative ones too. So here we go. If I plug in 1 into that, 2 times 2 to the, put the 1 right here where that x used to be. That gives me 2 times 2 to the 0. And if you remember, any number to the 0 power by definition is 1. So I replace that 2 to the 0 power with what it really is, which is 1. And that's why for this explicit function, when I plug in 1, I get 2. Let's plug in 2. Put my 2 right here where x used to be. That gives me 2 times 2 to the first. 2 to the first is 2. And then that 2 times 2 gives me the 4. Second word is negative. Negative. All right, now the hard ones. Now I'm going to start plugging in negative numbers into that exponent spot to show you how I get those smaller values. So here I go. If I plug in negative 1, into that same equation using the first term, but now I'm going to put a negative 1 right here. That gives me 2 times 2 to the negative 2. And again, by definition, any number to the negative power is the same as putting it over 1, flipping it, and having that negative power become positive. So 1 over 2 to the negative 2 power is 1 over 2 squared, which is 1/4. So I'll replace that 2 to the negative 2 with the number that it really is, which is 1/4. So here I go. And then when I times that 2 by 1/4, gives me 2 over 4, which is a half. So negative 1, that's the math to support why I get a half. All right, let's do it for negative 2. Plug in negative 2. That gives me 2 times 2 to the negative 3. By definition, 2 to the negative third is 1 over 2 to the positive third, which is 1 over 8. So I leave that 2 alone. 2 to the negative third becomes 1/8. And now when I put that straight across and times straight across, that gives me 2/8, which is the 1/4 answer right there. All right, so you can see when you're plugging in negative numbers in for x, I want you to see what's happening with that equation. A negative exponent is the same as flipping it over and having it be positive. Any number to the 0 power is 1. You need to know that. Any number to the negative power is the same as flipping it and having that negative exponent become positive. That's how I'm getting these small numbers. If I plugged in negative 3, that would be 2 to the negative 4 power, which is, yeah. All right. The third word is boat. Boat. Good luck. And then you can see these are all explicit. Be a line drawn through them. If these were recursive, would be dots. Good luck.